So, we are discussing about the experimental arrangement in last class. So, there are basically three established method to experimental method to study the crystal structure using X-ray diffraction. So, this for each method this is the Bragg law is used. Based on this Bragg law, so this experimental arrangement are done, and I have described, just mentioned the condition for each method. So, now I will describe in details. So, basically first one I was discussing, that is Lau method. So, that is Lau method. So, this in this Lau method, theta is constant, and lambda is variable. Right. So, d is there. So, we want to determine basically d. So, for each d, and theta is constant. So, lambda is variable, means so suitable lambda will be selected to satisfy this Bragg condition, right. So, we need experimental arrangement for this configuration. So, this so let me just sketch this experimental configuration. So, if I let me try. I think yeah. So, this is a small piece of a single crystal. I have shown you this silicon single crystal. So, this small piece of this single crystal is just I have done here. So, it is put on a head of a goniometer. Goniometer means you can change the angle. So, it is called goniometer. So, if I just let me So, this just I have there is a scaling of that. Okay. So, this, so just here so scaling are there of angle. So, one can just rotate the crystal to fix at a particular position. Okay. So, since in this case this theta is constant, so here so incident X-ray are falling, so X-ray are coming, so from X-ray source, X-ray are coming. So, say this is X-ray tube, so X-ray is coming, falling on the that crystal, and then it will be diffracted. It will be diffracted in all directions, right? So that's why. So satisfying this condition, it will diffracted in all directions, and then so it is diffracted. So we will get intensity for each direction of diffraction. So we have to now detect that position of those peak or what I should tell high intensity. So for that different way people detect. So earlier days generally this X-ray film were used. So I do not know whether you have seen or not this, but earlier days we used to for camera, for optical camera, we used to use this film, right, for photography film. So similarly for X-ray also these films are there, but nowadays it is digital screen are available. So on screen one can detect the intensity. Okay. So but we will discuss in terms of film, which was earlier used to detect the intensity on a space. So this so X-ray is from X-ray tube, X-ray are coming and falling on this sample, right. So this sample position we can fixed, we can rotate and keep a particular position, then angle with this crystal surface, that will remain same. Okay. So that means theta will remain constant. Okay. Whatever the planes are there, so if I do not rotate the crystal, so these planes are also fixed. So angle with different planes will be different, but they are fixed. So we are not changing the angle between the planes and the incident X-ray. Okay. So that is the geometry for fixing the theta constant, for fixing the theta at a particular value. Now to detect this intensity, so this photography plate were used. So this that photography plate, just if I put like this, photography one plate. So, this plate is hold with some arrangement. This so hold on a stand. Similarly, one more photography plate is used. So, say it is put here. So, it is hold on a holder, So, this is basically base. So, two photography plate is put, one is in forward direction and another is backward direction. So, basically this one is called photography plate in forward direction, and here whatever spot we will see that is basically forward due to forward reflection, and on the other hand this side we will see also the intensity variation or diffraction this side also. So, that is called back reflection, that is called back reflection. Okay. So, that crystal basically X-ray when falls it will diffracted in all directions. So, if you put this plate in any position you will see the intensity variation, you will see the higher intensity in different place. That is because of the diffraction in all directions, but in these two positions we are putting the film, and that is this arrangement is done this way, and that is why it is a one method. If I put this photography plate in other place, so that may be different method. So, this is not Lau method. So, in Lau method this way, this is the configuration of the experimental setup. Now, in this configuration what is happening, that we will see, we will get some diffraction peak recorded by this photography plate, X-ray plate, and from that different intensity of Bragg diffraction one can find out the structure of the crystal. So, that is the aim. Okay. So, now think that, so here X-ray is falling, now this is a crystal, single crystal. So, it has many planes, crystal planes, right. So, one plane is a set of parallel planes having a particular lattice constant. So, that is known, that we know. Now, that plane, apart from that plane there are many other planes in different orientations. So, in this crystal there are many sets of plane in different direction, they have different orientation, right. So, that is what we have seen. So, what will happen? So, let me draw a crystal. So, this I think I will okay. So, I have to draw in proper fashion. So, then we can Okay. So I think I have to draw more sharply. What I want to show, I think I have to draw this way. So this is the crystal. If I just draw in bigger way, if I just draw bigger way, okay. Yeah. If I draw in bigger way, okay. Okay, so this basically this one I have drawn in magnified way. So here, so this we have this extra false on this crystal. I think this is the middle point, maybe. Yes. Okay. So this is the direction. This is the direction, right? So now what will happen? This angle. So there is a set of parallel planes. If I just consider one set of parallel planes, so if I consider, okay, this is a so these all are equispaced parallel plane. So drawing is not proper, but if one can understand. So this is a set of parallel planes, right? Set of parallel planes. Now X-ray is falling, so it will make an angle with this set of parallel planes. So that angle is theta. It will make angle. So angle is theta. Okay. Now if this ray is central one, this if it is perpendicular to this set of planes, and looks it is perpendicular on these sets of parallel planes. So what will happen? So this incident angle is 90 degree, right? Gauging incident, this is gauging incidence. So it is along the normal of this planes. So it has a d spacing, it has a particular d spacing, right? So d is there. For that d, so this angle is fixed. This angle is fixed because I am not rotating the crystal, it is in a fixed position. So it will make angle with this set of parallel planes, that is theta, and that is constant. Okay. Now this incident angle is 90 degree, gauging incident angle is 90 degree. So it is along the normal. So what will happen? So it will just go. Also it can backscattered. Okay. So on this photography plate, what we will see? So what we will see? There is So, diffraction peak in this direction, and that is so high intensity along this direction, and it will be on this photographic plate. So, there we will see this one spot. So, say it is a white spot or black spot, whatever, depend on the photographic plate, and so this will give one spot here. Okay. Now, this is one set of parallel planes I have considered, but there are many sets of parallel planes, right. So, let me consider the another set of parallel planes. So, this is the let us see this plane. Okay. Okay. So, this plane, it's it can be the which plane, 110 plane. If these are the 100 plane or 010 plane or 001 plane, so this will be the 110 plane, right. So, that is there. So, this plane will, so there is a many parallel planes. 100 plane means there is a set of parallel planes. Now, this set of parallel planes will form an angle with this incident X-ray, right. So, let us tell that this angle is theta, gazing incident angle with this plane is theta, right. So, angle is theta. So, then that means the reflection will be also at angle theta. So, there will be from here, there will be from these sets of plane. Okay. So, incident angle with these sets of plane is angle theta, right. So, reflected one also will be angle theta. So, either it can be this side or other this side. So, depend on the inclination of the of this plane. So, let us tell that okay, this will be the one diffraction direction, right. Say reflected light, one diffraction direction. Okay. So, so this now 100 plane, if I consider 100 plane, not 100 plane, that is 110 plane. So, this also one, so this also another plane, 101 plane, whatever this family, as I mentioned, if you write 110 plane, right. So, it represents 110 plane, it represents 101 plane, it represents 011, right. So, 1 bar, so 1 bar 10 etc. So, these are planes form a family, right, and these all planes are basically equivalent, their orientation are different, there is a symmetry and number density on this plane, lattice point density on these planes are same, right. So, here not only these two planes, how many this type of planes will get? We will get these planes also 100 plane, 110 plane or of this family, right. This also, right. Okay. So, this also, so same plane, same planes. So, here you will get basically in different orientation equivalent plane, they are in 6 orientation basically. you will get in 6 orientation. Okay. And so angle, that theta here, this angle is theta, angle is theta. So if you are getting this from this plane, from other plane with the same angle, it will form the same angle, right. This theta is there, that theta, same theta, with the same theta, what will happen? See, okay. So from these two I can see one you will get this and another you will get this, another you will get this with the same angle theta, right. And this one, this plane and this plane, you see, if you see this inclination is this, so here your, this is the X-ray, this is the X-ray. So with this it will have some angle, and normal is this direction, you know, normal is this direction of these planes, right. So it will form basically this other, it will form a cone with this angle, all these 6 planes, it will be diffracted with this angle theta, and it will be, all this diffracted plane will be on the so all refracted other right. So same way you will get, here I am trying to draw 6. So 6 plane first you will get 6 spot, you will get 6 spot, okay. You will get basically, if I draw this way, so you will get 6 spot, right. So it will form a cone, basically it will form a cone with angle theta, whatever the angle it will make with this one of the plane. So with this, so this is the axis of this cone, the direction of the X-ray, incident X-ray, and taking this one as a axis of this cone, it, so with angle theta or true theta, it depends, okay. So so it will form a cone. On the surface of the cone, basically this diffracted rays will be there, and if you put here, your photographic plate, X-ray plate, so on this you will get this type of. So from another sets of planes with different angle, with different angle, say with this angle, say it can be, one can draw, say this is another sets of plane, if you consider another sets of plane, okay, if you consider another sets of plane, sorry. So if another sets of plane where this angle is will be different definitely. So for those planes, if they have symmetry, like these planes 1 0 0 1 1 0 plane I have shown, so if that type of symmetry is there, so all of them will have a on another all of them will have on another cone. So for all planes you will get cones, concentric cones, okay. You will get concentric cone, and each cone basically will have these are called low spot. So, this intense, wherever the maximum intensity, that is called low spot. So, we will get low spot. Okay. And this low spot here on this, so is convenient for me to tell about this symmetry 1 1 0 plane. So, you will have these 6 points on this. Similarly, for other planes, if depending on their symmetry, you will get the number of points on this. So, this way you will get basically many concentric cones, and family of these planes will be on a same cones, but for different families. So, like 1 1 0 0, this one family of planes, this another family of planes, etc. So, you will get this, and backscattered one, if you think this other side. So, you will get basically this opposite side also, you will get cone, you will get same cone. Okay. Okay. So, on that you will get spot. So, in Lau method, on the X-ray plate, what we will get? We will get this is the X-ray plate. We will get point. We will get so here this 6 point you will get, I think it will be yeah. So, 6 points you will get, 6 points you will get, what as I showed you, this it will show this symmetry, and this symmetry is basically whatever in spot you will get symmetry, and this symmetry will basically telling about the symmetry of the crystal 1 1 0 planes. Okay. Similarly, for other planes you will get. Okay. So, this way you will get spot, that is called Lau spot, and this Lau spot whatever you are getting, from there you can determine the crystal structure, but this method is mainly used to find out the symmetry of the crystal, okay. And looking at the pattern, one can basically find out the symmetry of the crystal. So, it is not done properly, I guess. So, this way one can find out, So, this way one can find out the symmetry. Okay. So, to know the symmetry of the crystal, one use this method and find out what are the symmetry of this crystal, even what are the surface. You see, whatever the because if we cut a crystal, and you can cut the crystal in such a way that its surface is parallel to a crystal plane. Okay. It can be 1 0 0 planes, or it can be 1 1 1 plane. Okay. So, if we have a crystal, and what is the surface plane, that to find out that one also use this method. So, these are the experimental arrangement and the purpose of this experiment. So, more details I cannot tell here in this course, because there are many things to analyze. Really one has knowledge, has to have knowledge, and from experience it comes, but these are the basic things of this method. So, in next class we will discuss the other method. So, I will stop here. Thank you for your attention.